Hi, this is part 5 of photoelectric emission. In this part, from now on we'll be doing only question bank questions. The theory part is in part 1, part 2, part 3, part 4. Okay, of photoelectric emission. So here we have Jan 2009. Here we have Jan 2009, Unit 2. Okay, question number 19, star question. They said a 60-watt filament light bulb, okay, is used as a ceiling light. The bulb is 2.5 meter above the floor at 5% efficient at converting electrical energy into visible light. At converting electrical energy into visible light. Okay. Calculate the visible light intensity. Can you see only 5% is getting converted to visible light? Okay. On the floor. So how much intensity of light is there on the floor below the bulb? We know the further away from the floor ceiling is, the less intense the light is. So assuming that the distance r, source of the energy is spread over a total area of 4 pi r square. So let's say this is floor, this is the ceiling, this is where the bulb is, and it is 2.5 meter above the r is 2.5 meter. Okay. So first thing first, let us see how much energy is getting converted, how much power of 60 watt is getting actually converted to power of light. So we know output divided by input, okay, into 100 is equal to efficiency. That's our formula, right? So now what is an output? We don't know how much is it. What is input? 60 watt. How much into 100 is equal to 5. If we do that, output we get, we have to use the calculator. It's 5 into 60. 5 into 60 divided by 100. We use the calculator. Okay, 5 into 60. There is something wrong. Okay, let me just see it again. Okay. Okay, it's working. So let's do 5 into 60. 5 into 60. Oh, it's not working. Okay, now it's working. It's 5 into 60. Okay, divide by 100. That's going to be 3. So that means 3 watts of power is getting converted. So from this 3 watt, we know intensity is equal to power by area. So how much area power is spread? So intensity is power by area. Power is 3 watt divided by area is 4 pi r square. 4 pi r square, how much is that? 2.5 square. If we do that in the calculator, it's going to be 3 divided by, I think it's not happening with the pen and it is happening with the mouse most probably. Okay, so 3 divided by 4 pi. Okay, 3 divided by 4 pi into 2.5 square. Now one mistake I did is I did not give any brackets over here, so let us do some brackets over here. Bracket is very important while doing calculations, remember that. Okay, so answer is 0.038. So if I want, yes, two significant figure, I can give my answer in two significant figure, that is 0.038. okay, watt per meter square. Let's see the mark scheme whether it matches or not. 0.038, yes, that is, or 0.04 is also acceptable with one significant figure. Okay, so this is over. Let's go to the next question. Now, increasing a different type of light, okay, increasing a different type of light bulb is being used. So we are using these days, nowadays, these things. It is a coiled fluorescent bulb, 10 watt. So where that was 60 watt filament bulb, this is 10 watt bulb. To replace the 60 watt filament bulb and give the same visible intensity, okay, on the floor. So you will get same visible intensity. Okay, so approximately 25% of the national power production is used for lighting. Okay, discuss why some countries have announced filament bulbs will be banned in next few years. One of the reason the filament bulbs gets heated a lot. Okay, less light is produced, less electrical energy gets, and most of them gets waste in the form of heat, and more fossil fuel is burned, and because of that more carbon dioxide released, and therefore it causes global warming. Okay, so that is the reason. Let's see mark scheme. Okay, reduction in carbon dioxide emission, if you use that, reduction in wasted energy as thermal. Okay, Okay, so sensible attempt to process values given fluorescent lamp much more efficient or filament lamp is less efficient. I hope you guys can compare this answer, combine this answer and just write it down. Okay, you have to write about efficiency. Filament bulb is less efficient, fluorescent bulb is more efficient. Okay, then there is a reduction if you use the reduction in wasting energy as thermal energy, and reduction is carbon dioxide emission, preserves fossil fuel resources. Okay, very important question. Okay, after this we will, there is another question in this paper. Okay, there is another question in this paper is this, if I'm not, no, not this question. Okay, this is also from Jan 2009, Jan 2009 U2. Okay, so this is about a diagram shows an apparatus for experiment on the photoelectric effect. A light is shown onto the cathode C and a potential difference is applied. Okay, so a light is shown in cathode C and a potential difference is applied between the cathode and anode A, between the cathode and anode A of the photocell. So there is a, so we know when the radiation hits it, if the light is more than threshold frequency, an electron from here will come over here, that we know. Okay, a sensitive emitter, so we have a sensitive emitter is used to detect any current that is flowing over there. Now, this light is replaced one by same intensity. So they kept the intensity same. So that means number of electrons should be same. I said this in previous videos. If the intensity is same, number of electron photons are same, therefore number of electron emitting is same. Therefore current is also supposed to be same. The results are shown below. Okay. So first light, you have photon energy of 1.8. You have, see, both of their intensity is 1. The work function is 2.3. So work function is 2.3 and the energy of the photon is less than work function. So no emission of electron takes place. Therefore the current is 0. Okay. Second light, it's more than threshold. What is it? It is more than, the photon energy is more than the work function. Therefore emission of electron takes place. Therefore the current is there. Explain why first emitter reading is 0. You have to say the work function, the energy, photon energy, okay, less than work function. Photon energy is less than work function, so therefore no emission of electron takes place. Therefore no emission of electron takes place, so no flow of current. Therefore emitter reading is 0. Okay, you can see that yourself. See, work function is 2.3, photon energy is 1.8. So if your photon energy is less than work function, no emission of electron takes place. Okay, now next is this. The experiment is repeated using the same for two photons energy, but intensities of the sources are increased. Add new emitter reading. So what did they do? They increased the intensity. Can you see the intensity was increased 4 times compared to before? Before the intensity was 1, now the intensity is 4. So that means your emitter reading, even if you increase the intensity, this energy is less than the work function. Therefore here the meter reading will be 0. It was 0 before, it will be 0 now. Intensity does not decide whether electron is emitting or not. The intensity decides how much electron is getting emitted. And can you see here, since the intensity is increased, your energy is just like before, your current will also increase 4 times, because your intensity is 4 times, your current will also increase 4 times. That it's going to be 4 5s are 20, 20 into 10 to the power minus 12. I hope you guys understood this. Okay, because the intensity has increased 4 times, therefore the current will also increase 4 times. Let's go to the next one. The cathode metal is lithium. Okay, the cathode metal is made up of lithium. Express the work function of lithium in joules. Okay, so we need to know the work function of lithium in joules. In a previous video I mentioned that 1.6 10 raised to minus 1 electrovolt is 1.6 10 raised to minus 19 joules. Okay, So if you want to convert this to joules, you should write 2.3 into 1.6 into 10 raised to minus 19 in your calculator. So this is how it's going to be. It's 2.3 into 1.6 into 10 raised to minus 19. Kota? 3.68 10 raised to minus 19. 3.68 into 10 raised to minus 19 joules. Okay, I hope that is the answer. 3.68 10 raised to minus 19. Okay, now ultraviolet radiation with a photon energy. This is the energy of the light, the energy of the photon. Ultraviolet radiation with the photon energy is shown onto the lithium cathode. So what is the work function? We know the work function in joules of lithium cathode. Okay, calculate the maximum speed of the electron. Okay, for this we need to know this equation. E is equal to hf. Okay, and hf equals to phi plus half mv square. Okay, now energy of the photon, we know how much is the energy of the photon. That is this. Hf is E, right? So energy of the photon is 4.8 into 10 raised to minus 18 equals to, what is phi? Phi we got was this, 3.68 into 10 raised to minus 19. Why is it 3 point? Because they said as the work function is 3.68 10 raised to minus 19 joules. I converted 2.3 electrovolt to joules, this joules. Okay, plus half mv square. Now we have to know the speed of the electron. If you want to find the speed of the electron, look, you need the mass. If you want to see the mass is given at the end of the paper. What is mass of one electron? See, electron mass is given to you, 9.11 10 raised to minus 31. So 9.11 10 raised to minus 31, okay, into v square. We are supposed to know this. Okay, let me just double check the mass of the electron. Did I write anything wrong? 10 raised to minus 31, 10, yes. Okay, now so the first thing you need to do is 4.8 into 10 raised to minus 18 minus 3.68 into 10 raised to minus 19 equals to half into 9.11 10 raised to minus 31 into v square. So let's do this in calculator. So if we do this in calculator, it's going to be 4.8 10 raised to, okay, let's do this in bracket. 4.8 10 raised to minus 18 close, okay, close bracket, minus 3.68 into 10 raised to minus 19. How much we got? 4.42 10 raised to minus 18. So 4.42 into 10 raised to minus 18. 432. It's okay. It got deleted. Okay, whatever. Equals to half, that is 0.5 into 9.11 10 raised to minus 31. So 0.5 into 9.11 into 10 raised to minus 31. Okay, so that's 4.55 triple 5 10 raised to minus 31. 4.555 into 10 raised to minus 31 into v square. So if I divide this with this, and root of the answer, I will get my answer of v. So let's see, 4.432 into 10 raised to minus 18, 10 raised to minus 18, okay, divided by the answer which we got, okay, root of the answer. So this is the speed of the electron. That how much is it? 1 2 3 4 5 6, 3.1 into 10 raised to 6, 3.1 into 10 to the power 6 meter per second. I hope this is the speed. Let me see the mark scheme. Okay, this was 22 if I'm not wrong. Which one was it? No. Yeah, this was the answer. Yes, first answer, energy of the photon is less than work function. Okay, so no electrons are emitted, 2 marks. Second, the current is 0 and it is 2 into 10 raised to minus 11. Okay, 2. Oh, 10 raised to 11. I got 10 raised to 10 if I'm not wrong. Answer of this minus 12. Okay, 11. Yeah, 2.0 10 raised to minus 11. I wrote 20. Same answer. 3.7 10 raised to minus 19. 3.7 3.68 10 raised to minus 19. I made a mistake. I'm supposed to take 3.7. Okay, whatever. And here it should be 3.1 10 raised to 6. Here it's going to be 3.1 10 raised to 6 is the answer. So this is done, this question. This is June 2009, question number 6. Okay, so we are in another paper, June 2009, question number 6. So they said the diagram shows some of the electrons energy levels for mercury atom. Okay, which of the lines A to D drawn on the diagram would correspond to emission? Remember, whenever they talk about emission, the arrow should be downward, and if they talk about absorption, arrow should be upward. If they talk about emission, the arrow should be downward, because when an electron is excited, it goes to higher energy level. When it absorbs energy, it goes to higher energy level. So for absorption, arrow should be up. So they spoke about emission of photon. Okay, when an electron comes down, then only emission of photon takes place. So B and D is automatically not the answer. So A and C is the emission, okay, of the shortest wavelength. Remember, shortest wavelength means high frequency, and high frequency means high energy. Now, out of this, which one will give you an high energy? It's going to be A. A should be your answer. A should be your answer. Why? A, the energy difference is high, and if your energy is high, energy is directly proportional to frequency. Frequency will be high, and if frequency is high, wavelength is going to be low. So here what are the hints to answer this kind of question? If they speak about emission, remember that you always should see the down arrow. Okay, if they talk about absorption, then see the up arrow. Okay, then they said shortest wavelength. If your wavelength is small, that means frequency is high, and frequency is high, energy is high. That means the energy difference is supposed to be high. So you can see C has an energy difference of 5.5 electrovolt. Okay, but A has an energy difference of 10.4 electrovolt. So its energy is high. Therefore, its frequency is also going to be high. Now we will go to next question after this. So this is our next question from June 2009 itself. It is same paper, June 2009 unit 2. June 2009 unit 2. Okay. So now they said the energy level diagram shows a ground state. Remember, the lowest level is always the ground state. This is the place where energy is most electron is most stable. Okay, and two excited E1 and E2. Okay, in a helium atom, in a helium neon laser, collision occurs between helium atom and neon atom. Okay, so helium and neon atom is colliding each other. This result in helium neon atoms being excited, okay, from the ground state to E2. So it becomes, whenever the electron gets excited, it goes to higher energy level. So it's going over here, E2. They emit photons. Okay, when they come down, they emit photons. Emission, this is absorption, this is emission. Remember that if arrow is down, it's emission. What is meant by energy level? Okay, it's better I give you guys this answer from mark scheme itself. Okay, what is meant by energy level? In mark scheme they give you many option. Okay, so energy levels are the possible energy of an atom. Possible, what are the total energy of an atom, or one of the energy of the atoms, energies of the atom. Okay, or you can just write energy an atom can have or an electron can have. Any one of these three you can write. Okay, this is the definition of energy level. Please write them down. What is the definition of energy level? Okay, it is a what are the possible energy an atom can have, or what is the energy an atom can have. So electron can have, atom can have, or possible energy of an atom, or one of the energy of the atom. Any one of these three definition you guys can write. Okay, now next what they said, what is photon? We already learned that photons are light particles with electro packets of electromagnetic energy. Okay, so they said photons is a packets or quantum of energy. Photons are packet, okay, of energy, packet of energy or particle of light. Photons are packets of energy or particle of light. Okay. Now, sorry, I went to the previous question. No. Then they said write a formula in terms of E1 and E2 for the energy of an emitted photon. So energy of an emitted photon is always the difference between two energy. So it's going to be E2 minus E1. This is the formula. The energy of the photon. Okay, this photon's energy will depend on from which energy level did it come back to which energy level. It depends on that. So difference in energy level. Okay, so did I write this properly? Okay, E1 and E2 formula in terms of E1 E2 the for the energy of an emitted photon. So it was at ground state to level E2. Excited from the ground state to level E2, they then emit photons and move to level E1. So it goes to E2. Let me explain this again. The electron goes from ground state to E2. Okay, then from there it comes back to E1, and when it comes back to E1, basically it's losing energy in terms of photons. Okay, so the energy of the photon is E2 minus E1. Remember that. Now the wavelength of the emitted photon is this. So we know the wavelength of the emitted photon. Calculate the energy of the photon. Okay, now we know energy is hc by lambda. Okay, h is 6.63 10 raised to minus 34. We know that h is constant value. C is also constant, 3 into 10 power 8 divided by lambda that has been given to us, 6.33 10 to the power minus 7. Okay, so they gave us the wavelength. They just tell us to find the energy of the photon, and wavelength and energy formula is this. This is exactly is equal to hf. Okay, instead of f we wrote c by lambda. Okay, now put this in the calculator and you will get the answer. So if we do that, it's going to be 6.63. We have to do this in bracket. 6.63 into 10 raised to minus 3. Okay, into 3 into 10 power 8. Okay, 6.33 into 10 raised to minus 7. Okay, I made some mistake. Okay, the bracket over here was not good enough. This is power bracket I gave. Okay. Let me just see how can I fix this. Okay, you know what? Let me not just give this bracket itself. Okay, 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 okay. Here I made the full mistake. Oh yeah, okay. Okay. Into 3 into number 8. Okay. So it's 3.14. Energy of the photo is 3.14 10 raised to 12 joules. I hope that is correct. 3.14. Okay, 10 raised to 12 joules. I think it's a lot. Let me just double check. 6.63 10 raised to minus 3. Okay, into 3 into 10 power 8 divided by 6.33 10 raised to minus 7. Okay, let me check the answers over here. How much answer they got? Mark scheme. 3.14 10 raised to minus 19. I told you so. There is something mistake I made over here. 3.14 10 raised to minus 19. I got 3.14. Just in the calculation, it's not correct. 6.63 10 raised to minus 34. 6.63 10 raised to minus 34. Okay, so let me just give 6.63 10 raised to minus 34. Yeah, 3.14 10 raised to minus 19 is the answer. Okay, so this question is done as well. Now we will move on to the next question. So this is June 2010. We are going to do from this paper June 2010 question number 5 and question number 17 if I'm not wrong. Just let me see. Question number 5 and question number 17. Yeah. Now let's read this question, June 2010, Unit 2 paper. This is, the diagram shows some of the electron energy levels for the hydrogen atom with 4 possible transition. Okay, so there are four possible transition that is possible for this electron. One is this. This is, this is absorption. This is emission, absorption, emission. The transition that would result in emission of longest wavelength. They said emission. So definitely which are going up is cancelled. A and C is cancelled automatically because they said emission. Emission means the arrow should be down. And they said longest wavelength. Longest wavelength means low frequency. And low frequency means low energy. Okay, low frequency means low energy because E is equal to HF. Okay, so D, because D the energy is less, so there its frequency is also going to be low. Okay, so D is your answer. Now let's go to question number 17. Okay, so they said the graph shows how the maximum kinetic energy um, E of the photoelectron is emitted. We did this graph in our tutorial, energy versus frequency. Remember, see that frequency is given in 10 to the power 14. Always check your units. And the energy is not in joules but in electrovolt. Okay. Now, explain why no photoelectrons are emitted below the frequency 10 into 10 to the power 14 hertz. They are talking about this. This is the threshold frequency. You have to say because it's a threshold frequency. And below threshold frequency, the energy is less than work function. Therefore, no emission of electron takes place. You have to say this is threshold frequency. Okay, which is below work function, in which energy is below work function. So therefore, no emission of electron. Okay, I hope you guys understood because this is threshold frequency. Below threshold frequency, no emission of electron takes place. Now, calculate the work function of aluminium in electron volt. Work function of aluminium in electron volt. Okay, the energy is also given to us in electron volt. So they're asking us. Okay, now we know the frequency E is equal to HF, right? Okay, and at threshold frequency it is work function. Remember, at threshold frequency only it is work function. Okay, so H is 6.63 10 raised to minus 34 into frequency, that is 10 into 10 to the power 14. 10 into 10 to the power 14. Let's put this in the calculator. We'll get an answer, but the answer will be in joules. Okay, because when we use this formula, our answer always comes in joules. So if we do that again, let me start again. Okay, if we do that again, it's going to be okay, bracket 6.63 into 10 raised to minus 34 okay, close bracket, into 10 into 10 to the power 14, 10 to the power 14, close bracket. Okay, so our answer is 6.63 10 raised to minus 19. 6.63 10 raised to minus 19. But thing is that this is in joules. If I want to convert joules to electrovolt, you have to divide it by 1.6 10 raised to minus 19. Okay, so we have to divide it by 1.6 10 raised to minus 19. So divide the answer with bracket 1.6 into 10 raised to minus 19. I hope this is correct. So it's around 4.14, three significant figure I took. So everything is in two significant figures. So let me just take 4.1. 4.1 electrovolt. Okay. Let me check the mark scheme. It's question number 17, right? Okay, let's go to the mark scheme. And let's see question number 17. It is 4.1 to 4.5 electrovolt. That is correct, 4.1 electrovolt. Okay. Now let's go to the next one. This is state the quantity represented by gradient of the graph. It's always energy versus frequency. The gradient of the graph is always Planck's constant. Remember that. Okay, Planck's constant. Add a second line to the graph to show how E varies, how the energy varies with frequency for a metal which has work function less than aluminium. So if you have a work function less than aluminium, that means your frequency will be also less than aluminium. But Planck's constant is always constant. Planck's constant never changes. So the gradient should be same. So if I'm drawing another line, what I would do, I think it should look something like this. Just let me copy paste this. Huh? I have a way of doing this. Wait, let me make the line thinner. Okay, medium. Okay, so this is the thing. Let me bring this and less right. Just give it somewhere over here. It should be parallel. Why should it be parallel? Because the value of h is same. The gradient should be same. Planck's constant does not change. Its work function was less, therefore its frequency is going to be less. Okay, but the line should be parallel to the original one. I hope you guys understood this question as well. We will go now to next question. So this is a new question of June 2011 question 12. The June 2011 GCE question 12. So they gave us an energy level diagram. It's in electrovolt. Everything is in electrovolt. The energies. It's about hydrogen atom. These are energy level diagrams of hydrogen atom. The diagram shows the lowest three energy levels of hydrogen atom. Excited hydrogen atom can emit light of wavelength so and so. Calculate the frequency of the light of this light. So we know the wavelength, we have to find the frequency. And they said it's a light. So this we know V is equal to F lambda, right? V is equal to F lambda. Now, velocity of the light we know very easily. What is it? 3 into 10 power 8. Okay, and frequency we have to find. And lambda that has been given to us. 6.56 into 10 raised to minus 7. So divide this. Frequency is 3 into 10 power 8 divided by 6.56 10 raised to minus 7. So let's see what we can do. So it's 3 into 10 power 8 divided by 3 into 10 to the power 3 into 10 to the power 8 divided by 6.56 into 10 to the power 7. Okay, how much is it? It's 4.5. The frequency is 4.5 hertz. I don't know what these brackets are. What did they give those? Okay, 4.5. Let me check the mark scheme first. It is question number 12. Okay, so let's see. It's 4.57 10 raised to 14. So what was the answer we got? Yeah, 4.57 10 raised to 14. So how come I did not get that answer over here in the calculator? 3 into 10 power 8 minus, I did not give minus 7. Okay, made a mistake. Yeah, yes, 4.57 10 raised to 14 is the answer of the frequency. So 4.57, 3 significant figure, because this is also given in 3 significant figure. So 4.57 into 10 raised to 14. Now the energy of the photon of this frequency is this much. So this frequency of light has an energy of this, okay, joules. By means of calculation, determine which electron transition emits this photon. So this is given in joules. They are asking you out of this, from where to where is this emission taking place. They said emission, can it be from this plate to this plate, or this energy level to this energy level, or this energy level to this? Where is it happening? We need to find that. Okay, so for that I need to convert this energy to electrovolt. Okay, and if you want to convert joules to electrovolt, 3.03 10 raised to minus 19 divided by 1.6 10 raised to minus 19. Okay, because I told you 1 electrovolt is 1.6 10 raised to minus 19 joules. So if you want to convert joules to electrovolt, division. Okay, let's do that in calculator. How much is that coming? 3.03 into 10 raised to minus 19 divided by 1.6 into 10 raised to minus 19. Okay, how much is the difference in energy? It's coming around 1.9 electrovolt. So the difference is around 1.9 electrovolt. So from here, what do I minus to find a difference of 1.9 electrovolt. This two, if I'm not wrong, let's minus them and see. 3.4 minus 1.5, how much is it? 1.9. So that means the electron is emitting from 1.5 to 3.4, from minus 1.5 to minus 3.4, because they said emission over here. Electron transition emits, so emission means it will come down, the arrow will be down, so it's coming from 1.5 to 3.4 is the answer. Okay, so this question is over. Let's go to the next question. So this is from the same paper, June 2011, if I'm not wrong. Same paper. Is it June 2011? Just double check. Yes, June 2011, question number 17 star. Okay. So they said in a demonstration, ultraviolet light is incident on zinc plate and electrons are getting emitted. So if you shine a light on zinc plate, electron gets emitted. The intensity of the ultraviolet light is increased. So I already mentioned to you before many times that if intensity increases, number of electron increases because the number of photon increases. Why? Because one-to-one interaction between photon and electron. So they said these are the observation. Number of photon electrons emitted per second increases. Why? Because number of photons per second increases, and each one photon interacts with one electron. Okay, and so therefore more photons, more electron per second gets emitted. Now this is the maximum kinetic energy of the electron does not change. You have to say energy is directly proportional to frequency. You have to write this formula, E is equal to hf. Energy is directly proportional to frequency, so the frequency is constant over here. The frequency is constant, therefore energy is also constant. Okay, so no kinetic energy, so therefore the kinetic energy of the electron does not change. Let's see the mark scheme, what they said. It's for question number 17. Okay, so they wrote mention photons. Okay, you have tried out photons. Idea of one relationship from photon to electron. Intensity high relates to number of photons per second. We said this. We also photon energy depends on the frequency, so we said this as well. Okay, the frequency is constant. We said this as well. So and okay, we already wrote 4 marks, but you have to actually write with the help of this as well. That wavelength is this is constant. This is constant. Therefore, your energy, kinetic energy is also constant. Okay, I hope you guys understood this. Remember, whenever they talk about intensity increases, you have to say photons per second increases. More photons, more electrons gets emitted because one-to-one interaction between photons and electrons. Very important line. Okay, now they give you many this thing, aluminum, cesium, potassium and zinc's work function. You can see zinc has the highest work function. Okay, now it is 10 raised to minus 19 joules. Okay, determine which of these metal would emit an electron when illuminated with a visible frequency. So out of this, which will allow an electron to come out with this frequency. Now let us see how much, what is the photon energy of these frequency. What is the photon energy of this frequency? How much? What is the formula? E is equal to hf. How much is h? 6.63 10 raised to minus 34 into frequency is 5.88 10 raised to 14. Okay, let's do that in the calculator. 6 point, if I use brackets, 6.63 into 10 raised to minus 34. Again mistake I was doing. Okay, into 5.88 into 10 raised to 14. So 3.89 10 raised to minus 19. 3.89 into 10 raised to minus 19. So this is in joules, but here okay, it's giving joules only. So that means this is my work function is supposed to be less than this. So cesium will emit, potassium will emit, but aluminium and zinc will not emit because the photon energy here is less than work function of zinc and aluminium. So no emission of electron for aluminium and zinc, but the photon energy is more than cesium, work function of cesium and potassium. Okay, they should get emitted. Let's see what they wrote in the mark scheme. Cesium and potassium, independent mark, calculate the minimum frequency 3.90 10 raised to minus 19. 3.90 10 raised to minus 19. Okay, so this, I hope you guys understood this as well. Now they gave us the graph shows how the maximum kinetic energy of the emitted electron varies. So these are the threshold frequencies. The gradient gives you Planck's constant. All of their gradient is h, remember that, because the lines are parallel to each other. Parallel lines have same gradients. Okay, emitted electron varies with frequency of incident light for the four metals. Okay. Okay, so how kinetic energy versus frequency graph varies for four metals. Okay, zinc and aluminum has a lot of frequency work function. Cesium and potassium doesn't. So before who was emitting, by the way? Cesium and potassium was getting emitted. Okay, use the relationship HF plus half mv square plus phi is equal to half mv square plus phi to explain the relative position of the graph and why they are all parallel. We know why they are all parallel because the gradient of the graph is Planck's constant. So Planck's constant is constant, it's gradient. Okay, so that's why the lines are parallel. um, and use the okay to explain relative position of the graphs. Relative position of the graphs, you can say that zinc and aluminum has high work function, so therefore they have very high threshold frequency. Potassium and cesium has low work function, they have very low threshold frequency. You can see that over here. Okay, and yeah, these are the only two lines, and the gradient is constant. That's why lines are parallel to each other. What is the gradient? Planck's constant. So let's see, refers to, okay, let's see what they wrote. Refers to E is equal to half mv square. Okay, gradient, because okay, gradient is h, all parallel because gradient h, 1 mark right there. Okay, required to release an electron. Okay, potassium will have smallest work function, zinc has the greatest work function. That's what I said indirectly. Okay, what else they used? Okay, phi is the intercept of the energy axis. Electron for metal is intercept of the frequency. Oh, this threshold frequency they are talking about. Threshold frequency, okay, is to release an electron for the metal is the intercept of the frequency axis. They are talking about x-axis. Okay, so we know these are threshold frequency. Wherever the line cuts the x-axis, that is the frequency axis. These all are threshold frequency. Okay, and zinc has the highest work function, potassium has the lowest work function. We can see that, and the gradients are parallel to each other because the gradient is Planck's constant. Okay, so 3 mark right there we got. Okay, phi is the intercept on the frequency axis. Okay, so this is done. Let's do the next sum. A school laboratory has a photoelectric cell for students to use. Okay, photoelectric cell. The metal plate in the photoelectric cell is made up of cesium, and it can be used with set of filters to obtain graphs similar to 1 in 2. So you can use it to get the graph which we got. Explain why metal is made up of cesium rather than zinc. Because zinc has very low threshold frequency, so it has a very low work function. So you can even emit electron with the help of visible light itself. You don't need to use UV light because UV lights are very dangerous. Okay, so you can use safe, just with visible light they can emit electron and do the experiment. They don't have to use uh, other forms of dangerous light such as UV light. That's why zinc is enough. Okay, yeah, let's see. They said zinc requires higher frequency. Oh, sorry, cesium is enough. Zinc requires, okay, zinc requires UV light. Okay, UVs are ionizing, they're dangerous. Cesium will work with visible light. Okay, I hope you guys understood. This is the last for part 5, 44 minutes video, and I have more questions for you guys. I'll slowly solve them and upload them. Okay.